Hi, welcome to Knowledge Center. In this video, let me explain you about the major components what we have in CPU. So in last video, I have explained about the architecture of 8051, wherein CPU plays an important role in the architecture of 8051. So let's see what actually it consists of. CPU consists of few major components. Let's see about that. So very first important thing is it is going to have some temporary registers like accumulator and register B. So these are the two special registers which are used in the accumulator to do all the logical and arithmetical operations. Generally, accumulator is used for performing all logical and arithmetic, even whatever the process we have, right? But the register B is used only with the instructions like MUL, that is the multiplication and division. It means whenever we go for a multiplication, we have to make use of these two registers mandatorily. So MUL AB, this is what the multiplication instruction is. We have to use A and B only. Then for division, again we have to use register A and B. It means these two are the special registers which are used for a special instructions. Okay, and these two registers are also having its own address. Now let us understand what is the address of register A and register B. So register A, the address of register A is 0E0 and address of register B is 0F0. This is the location where these two registers are addressed. Okay, and one more important thing you need to understand about these registers, that is the accumulator is a bit addressable register. Accumulator is a bit addressable register. Even the register B is also bit addressable register. It means both these registers are of 8-bit. Okay, let me just take an example here. Say this is 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 bits. Say this is accumulator. And the address of accumulator is 0E0. So you start from 0E0, 0E1 up to 0E7. So each bit can be altered without affecting the other bits. I can just means, for example, if I want to make this bit as high, for example, say 0E5, I want to make only this particular bit as high, then I can write an instruction called SETB, set bit 8.5. Then what happens in accumulator, only the 5th bit is going to become high, and we are not disturbing or we are not changing any other bits in the accumulator. This is the advantage of having a bit addressable process. So if this is possible with the registers, those registers are termed as bit addressable registers. So these two are the special function registers used for an arithmetic and logical operations in CPU. Okay, I hope it is clear for you. Even B will also be a bit addressable register. The same way you can understand it. Now let's take the another important register which we use in a which is available in the CPU, that is the stack pointer. In short, we name it as SP. Okay, stack pointer address. So first let us see what is the size of stack pointer, and also we shall understand the address of the stack pointer. The address of this stack pointer is 81H. This is the address where the stack pointer is, and always the stack pointer will be pointing towards 07. In a register bank, you know that there are 4 register banks are available in a microcontroller 8051, right? And stack pointer will be pointing towards 7. If you want to store the data in a stack pointer, then this will get incremented and data will be stored. So first let us understand what is the stack, okay, and what is the stack pointer. So stack is nothing but that we use it as a temporary registers in the process. Sometimes say during interrupts, especially during interrupts, we use this stack pointer. So you will understand the detail of stack pointer when we deal about the interrupts. But now for basically you just have an idea about this. Say if you are reading a book and if you want to do some other work, then now we close the book. But while closing the book, we will put something over there. We'll just place a marker or a pencil in that particular page, and we close it. So that when we come back to that reading mode, we should know where we have stopped, isn't it? The same way stack pointer will work like that. If program is executing, say there is a program and the address of this program, say this is a line which is executed. This address is of something, we say 001A. Now this 1A will be stored in stack pointer. Okay. If you want to store this into a stack pointer, say after this I want to do some other task. I want to jump to a particular program which is written here. Okay. So I want to jump here. So when you jump here, this address has to be stored somewhere. So that will be stored in stack pointer. That is the meaning over there. Okay. This is going to be stored in stack pointer. And how it will be stored? By using an instruction called push. If you are pushing something into a stack pointer, then we have to use an instruction called push. Okay, to write something to a stack pointer, we use an instruction called push. So when we execute this push, actually this stack pointer will get incremented by 1, so it will be 8, and this data will be stored over there. So in the location of 8, you will get 1A, right? So we are storing it by just incrementing it. So understand one thing: if you are writing something to a stack pointer, first it will increment and then write. Increment and write. This is about pushing the data into stack. If you want to read it back, so when we complete this program, we have to go back here. So the program counter should get this data into it. We have it in stack pointer, so we need to read it, right? So to read it, what we will do? First we read and then we decrement. This is what you need to understand. In stack pointer, first we read the data and then decrement. So when we decrement, we can read the other data over there. And for this, we use an instruction called pop. So push and pop are the instructions which are related to the stack pointer. So stack pointer is used to store the data temporarily. If you want to push the data, we use a push instruction. If you want to read it back, we will use a pop instruction. So in further sections, when we go for interrupts, there you will understand in detail about the stack pointer. Right off, as of now, we just understand this. It is used for temporary purpose, and we push it and we can read it by using pop. Okay. So this is a special register which is used in the CPU. Now let's take up the another register which is the most important thing used in the CPU. That is program counter. We name this as PC. This is the only register which does not have any address. Program counter is not going to have any address, no address. So if there is no address, then where it will be? See, the program counter is defined by an user. When we write a program, we start with this ORG 0000H. Okay. So this is the address we are giving it to program counter. That is the meaning here. So we have to define the address of a program counter. That will be done while writing a program. Okay. So that is one major thing you need to understand about program counter. And we have one more speciality about it. This is the only one register which is of 16-bit. The size of program counter is 16-bit. Anyhow, the microcontroller is of an 8-bit processor, but program counter is an 16-bit register. It will store 16-bit address in it. Okay. So this is the speciality. And when we switch on the supply, when we switch on the system, program counter will be always pointing towards 0000. But we can change it by writing a program like this. Okay. It will be pointing by default at 0000, but we can change the address. If you change that address, the program counter address will change. So that is the reason why we say it is not going to have any default, any address, fixed address. Okay. Right. So what actually program counter is? Now let's understand what is this program counter is. Okay. Program counter is nothing but it is going to hold an address which is to be executed next. Means, say at address 0000 you have written some line, we have move something else, and then at 0002 you have say add something else. So program counter will first hold this address, and once it is executed, the program counter will get incremented and it will hold the address of the next line which is to be executed. So in short we can say program counter is a register which is holding the address of the very next line which is to be executed. Isn't it? I hope it's clear. This is a register used to store the address of the very next line which is to be executed. That's the reason, or that is the important task of a program counter. So if program counter is not holding an address, then system will not understand where should I jump, right? So that is how it's going to play an important role in execution of a program. That is about the program counter. Next, let's take one more register which is used in the CPU, that is data pointer. DPTR in short we call it as DPTR. See, this is data pointer is also pointing towards the 16-bit address, but this DPTR is split into two, that is DPL and DPH. Actually this is a 16-bit, but further it is split into 8 bits. So one 8-bit we consider it as a data pointer lower byte, and the other 8-bit is called as a data pointer higher byte. So this 16-bit is split into two 8 bits. That's the reason we cannot call it as a 16-bit. We are splitting it here. And the address of this DPL is 82H, whereas address of DPH is 83H. See, here we have defined address for those data pointers, whereas for program counter we didn't have that. We can define it in a program, but here it is fixed. Okay. So whatever, for example, say if you are fetching a 16-bit address like 10200, then this 00 will be in DPL and 12 will be in DPH by default. Okay, when you write this DPTR, means I will take an example. Move DPTR hash 2000H. So if you write like this 00 is a lower byte. This lower byte data will be stored in DPL, that is the address location is 82H. And this 20 will be stored in 83H, which is known as DPH, higher byte of the data pointer. So we're just splitting, we are not storing that 16-bit in one register. We are splitting it into two and storing it. So if anybody asks you about how many 16-bit registers are there in a microcontroller, then without any hesitation, you say that there is only one 16-bit register, that is program counter. You may have a confusion about data pointer. Data pointer is also a 16-bit register, but further it is split into two 8 bits. So we are using it as a two separate 8 bits. So you cannot say that is a 16-bit register. I hope this is clear. This is about the some important points about data pointer. Now let us take up the most important thing, that is the flag register, which we call it as a PSW. PSW, it's nothing but program status word. So for this video, this is the final topic I am going to cover it, because these are the registers, or these are the special function registers which are used in the CPU. Okay, so PSW, as I told you, it is a program status word. This is also an 8-bit register. Now let's see what is that 8-bit consists of. You need to be very careful about this, because we are going to use it most regularly in the programming. So carry, first this will be a carry flag, then we get an auxiliary carry flag, then we get an F0, after that we get an RS1, then RS0, then we will have an overflow flag, after that we have one empty flag, then we have parity flag. So the address of this particular state PSW is 0D0H. So you have to remember all these addresses. Address of accumulator is 0E0H. Address of B register is 0F0H. Similarly, address of PSW is 0D0H. Now, if I say this is 0D0, this will be 0D7, and you should not change this positioning here. These are all predefined. The 0th bit of the PSW is a parity flag. This is the this is user defined, means it is left free for an user, he can define any bit over there. And this is overflow flag. These two are the bits used for setting of register bank, and this is a 0 flag used for an user defined. This is auxiliary carry, and this is carry. Okay, so this bit is going to talk about the carry bit. Okay, so here if there is any carry, when we add the numbers, if you get any carry, this is going to become high. If you get any auxiliary carry, then this is going to become high. Now let me clarify you what is the difference between the carry and auxiliary carry. Say if you are adding an 8-bit numbers, so 1 0 1 1 0 0 1 1, right? Let me take this as 1 here. Then again I will take 1 1 0 0 and take 1 1 0 1. Now let's see how to add it. See 1 plus 1, this will be 0 and 1 carry we get. Again we get 1 plus 1, so 0 and 1 carry here. Then 0 1 carry. Here we have 3 ones, so that can be represented as 1 and 1. See, this is most important here. So after nibble we got a carry. So the carry which is obtained after the nibble in the sense after the 4th bit. Okay, 1 2 3 4. After this 4th bit, if we get any carry, that is termed as an auxiliary carry. Okay, so this flag will going to become high if we get this. And now 1 plus 1, again 0 1, again we get 0 1 0 1 1 1. See, after the last MSB, if we get anything here, then this is carry. So this is the difference between the carry here. So if I take this is the 0 bit, D0, D1, D2, D3, D4, D5, D6, D7. So when you add the number from, if you are getting a carry from D3 to D4, then that is the auxiliary carry. If you are getting carry from D7 after D7, that is nothing but just a carry. I hope the difference between the auxiliary carry and carry is clear for you. Okay. Now this is user defined, and this RS1, RS0 are the registers used to select the register bank. See, in microcontroller we have 4 register banks: RB0, register bank 0, register bank 1, register bank 2, and register bank 3. Okay, and the location of all this register bank 0 is 00 to 07, and this is 08 to 0F. Next 10 to 17, 18 to 1F. These are the addresses of those register banks. So how to select the register banks? That will be a question now. To select this register bank 0, we have to give input for RS1 and RS0. So if I say this is RS1 and RS0, right? So let me give the inputs now. If I give 0 0, it will select by as a register bank 0 as a bank, which address is 0 to 7. If I put 0 1 in these 2 bits, then it will select register bank 1. If you want register bank 2 to be selected, you put 1 0 here. Here in these 2 registers, you just put 1 0, so that it will select register bank 2. Similarly, if you put both the bits as high, it will select register bank 3. Okay. So among these 4 register banks, I can select the register bank whichever we want by just changing the bits of RS0 and RS1. And one thing you need to understand here, this PSW is also a bit addressable register. It is also a bit addressable register, so that I can just write an instruction like this: clear PSW dot. So what is the number here? This is 0 1 2 3, third bit, and set bit PSW dot 4, fourth bit. If you write like this, I am making this 0, clear means 0, and I am setting this bit fourth one of PSW. So 1 0. If I write 1 0 here, then that is going to select the register bank 2. So this is how we can make a selection of register banks. By default, when you turn on the system, by default these two will be 0. So by default, always the register bank selected is 0. By default, register bank 0 is selected over there. If you want to change, you can write these 2 lines as a program and it will be updated. It will be selected as according to your data what you have given there. Okay. So because of this bit addressable, only I can change these 2 separately. If it was not a bit addressable, then I could have changed. I should think about all the other bits, right? That is the advantage of having a bit addressable option. Next we have overflow. This comes under the addition or multiplication. Whenever the data exceeds the range of the system, then overflow will become high. That overflow, if it is high, then that indicates that whatever the result I am getting, that is error. That is not the actual answer, because it is not having a storage capacity to store the data. That kind of data if you get, you will get this bit as a high. Then we have the register user friendly one user defined P bit. It is left free for user. Then we have parity. This is parity flag is nothing but what? It will tell you how many number means odd, how many number of ones are there in accumulator. In accumulator, say for example, in accumulator, if I have 0 0 1 1 1 1 0 1, so now 1 2 3 4 5, it will count the number of ones in that accumulator. Now I have 5 ones in it, so it is nothing but odd. Okay, so this parity flag will just tell you that whether the content of number of ones in accumulator is odd or even. Okay, it will not give the how many number of ones are there. It will just mention whether we have odd number of evens or even number of ones, odd number of ones or even number of ones. Say if it indicates 1, this is nothing but it is odd. If it is 0, then it is indication, this indicates that there are even number of ones. Now according to this data, I have 5 ones, that is odd. So this parity flag will become 1. That is an indication of odd number of ones in accumulator. So this will be done by the system itself. Okay, system will operate it. Even overflow, it is done by the system. Carry and auxiliary, it is done by the system. Whereas these two are under our control. We have to program it. Okay, these two are under our control. Right? So I hope this is clear. This is about the PSWR. These are the important parameters or important registers which are used in the CPU. So if you understand these registers basically strongly, then you can do the programming without any difficulty. You can do the programming. I hope this is clear for you. If it is clear, just press the like button and also share among with your friends. Okay, thank you.